Okay, we are on application page 157, and I'm hoping that you guys tried these problems out first. I really recommend you do that. Remember, we're talking about chemical formulas, chemical reactions, and there are, our first problem is sodium plus iodine yields sodium iodide. Now remember, we have two sides of this equation. It's kind of like an algebraic equation, but it's a chemical equation. And on the left-hand side are the reactants, and on the right-hand side are the products. That's the products of the reaction. So we have reactants, and these are the products. Now, the questions that they have for you is they need to balance this. The number of atoms on each side for each element needs to be the same. And if you look at this equation, you'll see that we have 2 iodine on the left, and we have 1 sodium on the left. But on the right, we only have 1 of each. So somehow we have to balance this equation. There is a hint on how to do these at the top of page 157. The first thing you need to realize is only the coefficients in an equation, not the subscripts in the chemical formulas, may be adjusted. Now let me explain that. The coefficients are the numbers that are out front of each one of these. Now there's no number, and we talked about that last time, that when there's no number, it's understood that the number is 1. So in this case, they are saying that the only thing that you can adjust is that number that's out front. The number that you cannot adjust is the subscript. For sodium, Na, there is no subscript, so it's understood that it's a 1. You can't adjust that. There's a 1 there. There's a 2 here. You can't adjust that because then you'd be adjusting the chemical makeup of this problem. And then on the right-hand side, we have sodium iodide. So there's subscripts there of 1 and 1. Again, that's understood. You can't adjust those. The only thing you can adjust is what's out front of each one of these. And then they want you to balance the element with the largest subscript first. So let's look at this problem that we have here. Which element has the largest subscript? Well, iodine has the largest subscript. So that's the one that we have to balance first. But it doesn't mean we have to balance the one on the left-hand side first. We just need to balance the iodine first because it's got the largest subscript. The third thing is, in an equation involving a pure element and 1 or more compounds, balance the pure element last. Here we have sodium. It's a pure element because there's only 1 atom in it. So you would balance that last because that's the easiest thing to balance. There's only 1 of them. So let's try and solve these problems. This first one, we pointed out that there's 1 sodium on the left, 2 iodine on the left, and in the reactants, or the products, on the right-hand side, we actually have 1 of each. So we're going to have to bump up, at least on the right-hand side, we know we're going to need 2 iodine. So if we put a 2 for a coefficient in front of that, we now have 2 of each of these. If we have 2 of each of these, we have to come back to the left-hand side and look and see, oh, well, we already have 2 of the iodine, but bummers, we only have 1 of the sodium. So we're going to have to increase the number of sodium. So you put a 2 in front of the sodium, that gives us 2 of each. And so now we're balanced. We have 2 of each element on each side of the equation. So our equation looks like this. 2 sodium plus iodine yields 2 sodium iodide. Let's look at problem number 2. I'd like you to try this on your own. If you could pause the video and try it if you haven't tried it already. So this next one is N2 plus H2 yields NH3. So we look at our products on the left-hand side, and we see we have 2 nitrogen and 2 hydrogen. And on the right-hand side, we only have 1 nitrogen and 1 hydrogen, or 3 hydrogen. And one of the things that they had told us to do was focus on the element that has the largest subscript. So let's focus on hydrogen. Hydrogen on the right-hand side is 3, and on the left-hand side is 2. So we have to think of multiples that will work with this. If we just look at the hydrogen, we know we're going to have to bump up the number of hydrogens so that it has a number that the hydrogen on the left-hand side can meet with. So let's bump this up on the right-hand side. Let's at least put a 2 for the coefficient. Now, for the number of hydrogen that we actually have 6. We have 2 times 3 would be 6. The number of nitrogen now is 2. If that's the case, we're going to have to put a coefficient on the left-hand side in front of the hydrogen. What coefficient do you think it would be? We have to have a total of 6 elements. So if we want 6 down here, we're going to have to put a 3 in front of that hydrogen. Now, does that look like it's balanced? We have N2 plus 3H2 yields 2NH3. That's a balanced equation. You see that we have the same number of atoms on the left and right hand side for the products and the reactants. Let's look at number 3. This is decomposition of potassium chlorate. It has a few more chemicals in it. Potassium, chlorine, and oxygen. And that is going to yield potassium chloride plus O2. And one of the hints they gave us was to work with the element that has the largest subscript. So if we look at the left-hand side, let's go ahead and write out how many of each of these we have. We have 1 potassium, 1 chloride, and we have 3 oxygen on the left-hand side. We have 1 potassium, 1 chloride, and then on the right-hand side we have 2 oxygen. So we have a very similar problem that we had last one in which we have to have multiples. So if we decide on the right-hand side to increase the oxygen to 2, you'll see that the total number would now be 4 on the right-hand side. And if we look at the left-hand side, we can't do anything about that. We can't get this 3 because it has to be a multiple. We have to put a number out front here of this right here in order to make this equal. So a 2 is not going to work for us. But let's try a 3. That would make this a 6 on this side. If we did a 6 on this side, so 6 oxygen, we definitely know we'll have to put a 2 here. If we put a 2 here, we now have 2 potassium, 2 chloride, and 6 oxygen. Well, we're still not balanced because the potassium chloride, now we have 2 on this side. We're going to have to change these. So we want to get 2 of each of these. In order to do that, we just put a 2 out front. Now we have 2 of each one of those elements. Let's look at problem 4. Try and do this one on your own again. This is synthesis of phosphorus trichloride. So we have P4 plus Cl2 yields PCl3. Let's just put our total number of atoms on each side. So for P we have 4, and for chlorine we have 2, and on the right hand side we have 1 and we have 3. So we're going to have to think of some multiples. So the first hint that they gave us was we need to work with the element that has the largest number, which would be phosphor. So if we have 4 on the left-hand side, we know that we're going to have at a minimum, let's go ahead and try to put a 4 on the right-hand side. If we put a 4 here, that means our number of potassium is now 4, and the number of chloride is 12, because 4 times 3 is 12. So that means we have to come to the left-hand side. We're good with the 4, and for the chlorine, we're going to have to make this a 12. So if we want a 12, we're going to have to multiply this by 6. So now we have a balanced equation. Let's look at problem 5. This is one where you're producing hydrogen from hydrochloric acid. We have Zn, which is zinc, plus HCl, hydrochloric acid, yields zinc chloride plus H2, which H2 is a gas. Let's see how many elements we have on each side. We have for zinc, we have 1, hydrogen, we have 1, chlorine 1, we have 1 of zinc, 1 of chlorine. Oh, we have 2 of the hydrogen. That messes things up. So we're going to use the element that has the greatest number for their subscript, which would be hydrogen. We're going to have to adjust that first. So we know we have to use a 2 on the left-hand side. That means it's going to increase these to 2. If we use a 2 on the left-hand side, now on the right-hand side, we're going to have to increase the zinc to 2 because we need the chlorine, or the zinc chloride to 2. So we need to change these. Now these are 2. So each one has 2 in it. 2 zinc, 2 chloride, 2 hydrogen. So that means we have to increase this to 2. If this is a 2 here, we have to increase that to a 5. But I actually did this problem wrong because the products that we have are actually listed differently. So let me redo that part. This should have had, over here, we should have had a 2. So that causes a whole problem in how we do it. Let's redo that. We actually have zinc plus HCl yields zinc chloride plus H2. So hydrogen and chloride, they both have 2 in it. Let's go ahead and bump this up on the left-hand side. So we have 2 hydrogen, now 2 chloride. And for zinc, we only have 1. On this side, we have 1, 2, and 2. Does that look like it solves the problem? It's actually a lot easier than the last problem I did. Okay, let's look at problem 6. We have carbon monoxide, CO, plus nitrogen oxide yields carbon dioxide plus nitrogen gas. So we have to balance this. If you look on the left-hand side, we have 2 oxygen. We have to add them up from the 2 different ones. For nitrogen, we have 1, and for carbon, we have 1. On the right-hand side, we have 1, 2, and 2. So you see that we have enough of the carbon and oxygen on the right-hand side, but on the right-hand side, we also have too many nitrogen. So somehow we're going to have to adjust. We can't adjust any coefficient in front of this because the minimum we can have is a 1. We can't put 1/2. So we have to at least put a 2 over here in front of this nitrogen oxide. If we put a 2 in front of that, that means this becomes a 2, which is great. But that means we have 2 oxygen here and 1 here and 1 here, or 2 there, so that means we're up to 3. If we have 3, that means we don't match on the right-hand side. So somehow we have to match. So why don't we do this, where we put 2 carbon and 2 oxygen. So now we have 2 carbon, and we have 1 more oxygen. So we have a total of 4. So it's 2 of those oxygen, 2 of these oxygen. You add those together, we have 4. Now, that means on the right-hand side, we would at least need a 2 in front of this to make this 2 carbon, and 2 times 2 for the oxygen would be 4. So now we have a balanced equation. So I hope you guys have all tried to do these on your own. If you haven't, look at these, and the goal is to balance the equations so that we have the same number of elements on the left and the right-hand side. Thanks.